If the radius of a right cylinder decreases at the rate of 1 meter per hour, while the height increases at the rate of 5 meters per hour, at the instant the cylinder has a radius of 4 meters and a height of 10 meters, find the rate at which the A, volume changes, and B, surface area changes. The best thing to do here is to write down the information given. The first thing given is the rate at which the radius changes, r prime, or dr dt. Since it's decreasing, it will be a negative, and it has a rate of 1 meter per hour. Also given is the rate at which the height changes, h prime, or dh dt. It's increasing, and therefore will be positive, and has a rate of 5 meters per hour. Also given is the radius, 4 meters, and the height, 10 meters. For part A, we want to find the rate at which the volume changes, V prime. The volume of a cylinder is pi times the radius squared times the height. The radius and the height are not related in this situation here, and therefore the derivative of the right side will require the product rule. We have the related variables equation. We're now going to take the time derivative of both sides to produce the related rates equation. The time derivative indicated by the prime on both sides. Every variable is implicit with time. Every variable will have a prime in its derivative. On the left side, the derivative of v will be 1 times b prime. On the right, we have a product of two variables, r squared times h. The derivative of the first, the pi r squared, bring down the power, multiply it with the pi, subtract 1 from the power, multiply by the derivative of the inside to complete the chain rule, and then times the second left alone. Plus the first left alone, the pi, times the r squared, and then the derivative of the second, the derivative of h is 1, and then times h prime to complete the chain rule. Every time we take the derivative of a variable, we get a prime due to the chain rule, because every variable is implicit on time. We can now plug numbers into this to find v prime. 2 pi times r, 4, times r prime, negative 1, times h, 10, plus pi times r squared, 4 squared, times h prime, 5. So v prime is now equal to 2 times 4, which is an 8, times a negative 1, which is a negative 8, times the 10 is negative 80, and then times the pi, plus pi times 4 squared, which is 16 times 5. So v prime will be negative 80 pi plus 16 times 5 is 80 pi. Those will cancel each other out, and so v prime will come out to a 0. Therefore, v prime, or dv dt, the rate at which the volume changes, is going to be 0. It still has units. The units will be volume, length cubed. We're in meters in this problem, so meters cubed, over time, hours. For part B, we want to find the rate at which the surface area changes. Now, just because the volume is changing at a rate of 0 does not mean the surface area will also change at a rate of 0. They are different functions and may change at different rates. The surface area of a cylinder is made up of its curved side wall, which has dimensions of circumference, 2 pi r, times height, h, and then it has the two end caps, the two circles capping off the top and bottom. Each of those have an area of pi r squared. There is 2 of them, giving us 2 pi r squared. There's our related variables equation. We can now take the time derivative of both sides to produce the related rates equation. On the right side, the first term is a product rule for the derivative. The second term is just a power rule. So I will indicate the time derivative of both sides by a prime on both sides. Every variable is implicit with time once again, so on the left the derivative of s is 1 and then times s prime. On the right we have the product rule of 2 pi r times h. The derivative of 2 pi r is 2 pi but then times r prime times the second left alone, h, plus the first left alone, 2 pi r, times the derivative of the second derivative of h is 1 but then times h prime. The derivative of the second term is a power rule. Bring down the 2, multiply it with the 2 pi, that becomes 4 pi. Subtract 1 from the power, r to the first power, and then multiply by the derivative of the inside to complete the chain rule, r prime. We can now plug our numbers in. So s prime will equal to 2 pi times r prime, which is a -1, times h, which is a 10, plus 2 pi times r, which is a 4, times h prime, which is a 5, plus 4 pi times r, which is a 4, and r prime, which is a -1. So s prime will equal the first term, 2 times the -1, -2 times the 10 is -20, and then times the pi, plus 2 times 4 is 8 times the 5 is 40, and then times the pi. And then 4 times 4 is a 16 times the -1 is -16, and then times the pi. So s prime comes out to -20 plus 40 is 20, and then minus 16 is 4, and then times the pi. Therefore, s prime, or ds dt, is coming out to 4 pi. So the surface area is changing. It's a positive, therefore it's increasing. This will have units of surface area, units of area. Area is always length squared. We're in length of meters here, so meters squared over time, which is in hours, 4 pi meters squared per hour.